Now, check if the output voltage and frequency are within limits and make your decision. You're right, AC voltage and frequency are correct. Now, we can bring the generator online. Go ahead. We repeat these actions for generator 4. Have a look at the power distribution now after we brought the generators online. The generators are powering their respective channels, and the APU generator has no load but is ready to resume load should an engine generator fail. Depending on your airline policy or local performance considerations, the APU may be left on for takeoff and initial climb. It is then shut down according to your standard operating procedures. When the APU is shut down, the APU generator control switch remains at the on position. The APU generator offline warning will not illuminate in this case because there is no power to the generator. The warning will come on when the APU is running, but the generator control switch is at off reset or offline. Do it, please. The APU will be restarted during approach or after landing, depending on your airline policy and performance considerations. As the APU generator control switch is on, the APU generator is automatically established as reserve power source in the electrical system after APU start. Before we switch any engine generator off, we have to make sure that the APU generator output is correct. As you can see, the output is correct. Now, we may switch off the engine generators and the engines, but we have to make sure that the flaps are not moving when we do the power switching. The reason is that a power interruption could cause a flap fault. As soon as the previous is assured, we can switch generator 1 to off reset position. Go ahead. Then generator 4 is switched off, and thereafter the APU generator is powering the whole electrical system. Go ahead. When the aircraft is parked, an external AC supply can be connected by ground personnel. We have to check the quality first before selecting external AC to on. If the output of the external AC supply is correct, switch it on, please. Note that the switch returns to its central position. Go ahead. No indication is given that the external AC is now armed and waiting in reserve. But there is load indicated on the APU amp meter, which indicates that the APU generator is still powering the bus bars. When we shut down the APU, external AC will be selected automatically to power the entire bus bar system. Do it, please. When performing the leaving aircraft items, we switch off electrical power in the following order. First, external AC is selected off, and thereafter the batteries are switched off. Go ahead. If after shutdown power is needed in the cabin for servicing, cleaning, or lighting, the power switch on the forward cabin attendant panel is set to on. Note that this switch is also returning to its central position after on selection. This chapter does not look at the start process itself, but at the changes made to the electrical system to support engine start. We will look at the preferences for power supplies first, and then at the configurations of the electrical system during start. Each engine has its own DC starter motor powered by the start bus. Note that the start bus is separated from the main DC bus bar network. This is the order of preferences for powering the DC start bus. First, AC power converted to 28 volts DC power via both TRUs. Then 28 volts external DC, and finally via the two aircraft batteries. If the engine starting is performed during pushback, the APU would normally be used to power the start bus through both TRUs. When the APU generator is used for engine starting, the APU air must be set off to reduce the load and thus the EGT on the unit to prevent an auto shutdown. When the aircraft is stationary and external AC is available, the engines can also be started with external AC powering both TRUs. Note that the external supply must be rated at 60 kVA minimum. Should both external AC and APU be unavailable or a TRU unserviceable, the engines can be started from external DC. The supply must be 28 volts and be rated at a minimum of 2000 amps. Battery power can be used to start an engine as last option if two batteries are fitted and this option was enabled. Engine 1 or 4 would be started, and thereafter the other engines with the respective engine generator. In our example, we have started engine 4 on battery. Generator 4 is brought online and the N2 of the engine is increased to 65%. Now we can start the remaining engines with power from generator 4 through both TRUs. Another option is to leave either engine 1 or 4 running during a turnaround on ground in order to have electrical power available if neither APU nor external AC is available. Note that this is not a standard procedure, as it is quite hazardous to ground personnel. We have looked at the different electrical power supplies for engine starting. Now we go on to the configuration of the electrical system during engine start. The current needed for electrical engine start is so high that it cannot be supplied by a single TRU. We need both TRUs for engine starting when using converted AC power. The TRUs in turn must be powered by a single AC power source to ensure a balanced flow through both TRUs. If two AC power sources would be available, the starter motor can be damaged. This would be caused by the change in load on the starter motor in case one power source fails and the other one takes over after a short interrupt. It is the flight crew's responsibility to confirm that only a single power source is connected before engine start. During engine start, the electrical system is automatically configured so that only one power source is connected to the busbar system at a time.